Hello class, today we are going to talk about the properties of trapezoids. And before we do that, we do need to talk about what is a trapezoid. And a trapezoid is a quadrilateral with exactly one pair of parallel sides. So this is not a parallelogram, because it exactly one set of parallel sides. So it could look like this, could look like this. These are trapezoids. And I do want to point out that if I do take this and I bring it out like this and turn it into a rectangle, it ceases to be a trapezoid, okay? This is not a trapezoid anymore because now I have two sets of parallel sides, and a trapezoid must have exactly one set of parallel sides. If it has two sets, not a trapezoid. Now it turns into a rectangle, which is a parallelogram. All right. This is a trapezoid, has exactly one set of parallel sides. So, a couple of things, little definitional stuff. Trapezoids have two bases. Those are the parallel sides. We call those the bases. So that would be side DC and side AB. Those are the bases because they're parallel to each other. The legs are the sides that are not the base. Those are the sides that connect the base. They are not parallel to each other. And then you have base angles. Okay, base angles are angles on the same base. So A and B, those are base angles. D and C, those are base angles. All right. So there's that. When we talk base angles, we would not talk A and D because those are on different bases. Okay. One other thing we have, angles that share a leg, so on the same leg, are supplementary because again, though we have parallel lines cut by a transversal, and so that would be same side interior angles. Right? And same side angles are supplementary. So A and D would add up to 180, angle B, angle C are supplementary. Other thing we have is the midsegment. The midsegment of a trapezoid, just like the midsegment of a triangle, connects the two midpoints. Now, one thing about trapezoid is it always connects the midpoints of the legs, not the midpoint of the base. Okay, there is no midsegment connects the midpoints of the bases. The midsegment always connects the legs, and because of this, the midsegment will be parallel to both of the bases, and it will be equal to half the sum of the lengths of the bases. Remember, in a triangle, the midsegment was half of that side it doesn't touch. Well, here it's got two sides that it doesn't touch, so you add them up. It's half of those two sides added up, right, which makes it the average of the bases. So let's take a look at this real quickly. So here we have trapezoid PQRS. It tells us segment M is the midsegment, and notice it is the midpoint, right? It's equidistant on both sides. We want to find the length of MN. Well, as we said, the midsegment is half the lengths of the bases added up. All right, so it's going to be half of PQ plus SR. So that would be 1/2, plug in the numbers, substitute that in. So we have 12 plus 28. And we can stick that in the calculator and we get 20. All right, 12 plus 28 is 40. Half of 40 is 20. And so the length of our midsegment MN is 20 inches. All right, so pretty easy stuff. Now, there is a special case of trapezoid, which is the isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. All right, so here we have a trapezoid because DC is parallel to AB, and it's isosceles because AD is congruent to CB. All right, just like isosceles triangles has two congruent legs, isosceles trapezoid has two congruent legs. All right. And it has to be the legs. If you have a leg congruent to a base, that's no good. That's not going to give you an isosceles trapezoid. I do have a couple of properties about isosceles trapezoid. Number one, the base angles of an isosceles trapezoid are congruent. Okay, so just like in isosceles triangles, the base angles are congruent. In isosceles trapezoids, the base angles are congruent. Now, this doesn't mean all of the angles are congruent. Okay. Just the angles that share a base. So angle A is congruent to angle B, angle D is congruent to angle C. One thing that's very important, opposite angles are not congruent. In a trapezoid, opposite angles are never congruent, okay? Because if the opposite angles were congruent, then that would force this into being a parallelogram, which this is not. It only has one set of parallel sides, not two. Other thing about isosceles trapezoids is the isosceles trapezoid diagonals theorem. The diagonals of an isosceles trapezoid are congruent. So segment AC is congruent to segment BD. Now, one thing very important, notice that these diagonals do not bisect each other. It is not a parallelogram. It is not a rectangle, never will be, and so the diagonals do not ever bisect each other, okay? Which is why this segment is not congruent to that segment. All right. So, what we're going to do real quickly, we want to find the measure of each angle in the isosceles trapezoid, okay? Notice my legs are congruent, so this is isosceles, also tells me in the problem. Okay, well, the first thing, easiest thing, isosceles trapezoid, so the base angles are congruent. So that means M is congruent to which angle? Well, let's see here, the one along the base. Well, these two are the parallel lines, so those are the bases. So we would move along the base, and that would be angle L. So angle M is congruent to angle L because those are base angles. So that's 23. What do we do with the other ones? Well, remember, as we said a minute ago, at one of those earlier slides, the angles that share the same side, that share a leg, are supplementary. Because again, we have same side interior angles between two parallel lines. So that means that these two angles are supplementary. For angle J, we take 180 minus the measure of angle M, and so we end up with 157. And so the measure of angle J is 157 because base angles, angles that share a leg, same side interior angles, are supplementary. And angle K, well, angle K is on the same base as angle J, so that's base angles being congruent again. And so angle K is also 157 degrees. All right. And that is trapezoids. So just to refresh, in every trapezoid, you have exactly one set of bases, one set of parallel sides, which we call the bases. The non-parallel sides are the legs. Base angles share a base on the same base, and angles that share a leg will be supplementary. Notice if it's not an isosceles trapezoid, angles, the base angles, not congruent. All right, here angle A is pretty close to being a right angle, and angle B is very definitely obtuse. Right? So, not an isosceles trapezoid, the base angles are not congruent. In any trapezoid, the mid-segment connects the midpoints of the legs, not the bases, and the mid-segment is parallel to both bases and is the length of the bases added up and divided by 2. All right. In an isosceles trapezoid, the legs are congruent, base angles are congruent, and the diagonals are congruent. Opposite angles will never be congruent, and the diagonals will never bisect each other. A trapezoid will never be a rectangle. All right? So it has to have exactly one set of parallel sides. If it has more than that, it's not a trapezoid. All right, and that's that. Hopefully you found that useful, and I will see you in the next video.